This video is on the Chapter 9 D-Day number 2, which is the classwork for Wednesday for period 3 and 5, and Thursday for period 6. This is getting us ready for our tests that we're going to be having on Friday. I shouldn't say test, quiz that we're having on Friday. So this D-Day was posted. I had it on the stream for us today, but you want to get it from the classwork on the Google Classroom, because then you can edit it. Okay, you can't edit it if it's on the stream. Okay, you can print it out if you want. You can do it on your phone or tablet, or you can do it on a separate sheet of paper. So let's get started with the first problem. Okay, so for this, what we're going to be doing is we're going to be solving for x with this inequality. I'm going to add 2 to both sides, and I get 7x. 7x is less than 28. Then when I divide, okay, I'm going to divide by 7. When I divide by a positive number, my inequality does not change direction. So I'm going to get x is less than 4. That's what you put here for solution. Okay, x is less than 4. And then on your graph, you want to make sure you put the number 4 there. I want to see the number. And you want to make sure you emphasize open or closed circle. Don't just shade up to. I want to see open circle or closed circle. And this one's going to be open, okay? Open circle. So I'm going to have an open circle. And if your x is on the left-hand side, like this one is, your inequality is actually going to shade the direction that your inequality is pointing. That is your graph. This is your answer. Again, this is x is less than 4. These are values that are less than or smaller than 4. But if your x is on the left-hand side, it's going to be shading the same direction your inequality is pointing. Okay, so now let me move on to number 2. So on number 2, on this one, you want to be careful. Your x is on the right-hand side. Now you can keep it here on the right-hand side, that's fine. But you just want to think before you graph your answer. So I'm going to add 12 to both sides. And I'm going to get 30 is less than or equal to 6x. I'm going to divide both sides by 6. And I end up with 5 is less than or equal to x. Again, I do not switch the direction of my inequality if I divide by a positive. So that's my answer. 5 is less than or equal to x. So here's my 5. Is it going to be open or closed circle with that little line? It's going to be closed. So I'm going to have a closed dot. Okay, emphasize that it's a closed dot. And then this is where you have to be careful. Your x is not on the left-hand side. It's on the right-hand side. So it's not going to be going the direction it's pointing. It's actually going to go the opposite direction. That is your graph. Now, if you like to have your x on your left-hand side, we can get our x on the left-hand side. I can subtract 6x so that my x is on the left-hand side. And I would get negative 6x plus 18 is less than or equal to negative 12. I am then going to subtract 18 from both sides. I'm going to do it in my head because I'm getting a little close to this. So I'm going to have negative 6x is less than or equal to minus 18 here gone, minus 18 here. I get a negative 30. And now what's going to happen is I'm going to divide by a negative 6. But when I divide by a negative 6, let me get a highlighter here. I need to switch the direction of my inequality. So this answer is going to be x is greater than or equal to 5. So you see this does match with my graph. So if you have your x on the left-hand side, you can shade the direction it's pointing. If it's on the right-hand side, it's not going to go the direction it's pointing. It's actually going to go the opposite direction. Okay, let's take a look at number 3. So on number 3, I'm going to, my x is on the left-hand side, so I like that. I'm going to get my x by itself, so I'm going to minus 5, and I'm going to get negative 4x is less than or equal to 12. Now, I have a negative in front, so I'm going to divide both sides by a negative, And remember, when I divide by a negative, I need to switch the direction of my inequality. That is the only time you're going to switch it, is when you multiply or divide by a negative number. So this is going to end up being x is greater than or equal to -3. And that is my answer that I write here. I'm going to put -3 on my number line. I am going to decide if it's open or closed, and this one is closed. Okay, this one is closed. So I'm going to have my closed dot. And it's greater. Again, notice the x is on the left-hand side. My inequality is going to, my shading is going to go the direction my inequality is pointing. And that's your answer. So I'm just going to make a little reminder. If divide by a negative, switch inequality direction. Okay, or multiply. In this case, I divided. So if you multiply or divide by a negative, you're going to switch the inequality direction. And let me just highlight that. Okay. Okay, so let's take a look at number 4. So number 4 is like the problems that I went through on Monday or Tuesday, depending on what day you had me, where we had the special cases. Okay, so you'll notice you have a -8x and a -8x. I am going to try to get my x's on the same side, but when I'm doing that, because it's the same on both sides, they're going to cancel out, and I'm going to be left with 10 is less than or equal to 15. And you want to ask yourself if this is true or false. Okay, because sometimes it could be all real numbers and sometimes it could be no solution. So in this case, is 10 greater than or equal to 15? False. So that means my answer is no solution. And do not put anything on your graph. I don't want to see the 10. I don't want to see the 15. Your graph is what makes the inequality true, and nothing makes inequality true, so you should not have anything on your graph. Okay, number 5. Number 5 is an absolute value equation. The only time you write two equations is if it's absolute value. So on ones like this, do not give me two equations. There's no absolute value, okay? On this one, you're going to give me two equations. Now, the first thing you want to do is make sure your absolute value is isolated, which it is. Then you want to check the sign of the number over here and see if it's positive or negative. It is positive, so we're good to go. If it was negative, if this had been a -13, our answer is no solution. We're done. Okay, so I'm going to write 2x minus 3 equals 13, and 2x minus 3 equals -13. And I'm going to solve both of these. So I'm going to add 3. Okay, be careful with your math. Some of us are getting a little sloppy with our math. This is going to be 2x. These cancel out. Make sure you add these. Get a 16. Divide both sides by 2. And I get x equal 8. That's one of your solutions. Now I'm going to do the same over here. I'm going to add 3. I get 2x is equal to -10. So x is equal to -5. Both of these are answers. Some of us get concerned because you get a negative here. You can get a negative answer. You just cannot start with your absolute value being equal to a negative, because absolute value is either 0 or positive. It will never become a negative. Okay, so that's an okay answer. Okay, now 6. This is absolute value inequality. So I would probably look over here and see if it's a 0 or a negative. And then you can sit there and reason through it without actually doing the math, okay? Because this is always going to be positive or 0. And then you can kind of compare and see if it's a true statement where maybe everything's a solution, or a false statement where nothing's a solution. Or maybe it's one single point or something like that. But in this case, it is a positive. Okay, so again, we see it's a positive and it's isolated. So I'm going to go x minus 4 equals 10, and I'm going to go x minus 4 equals negative 10. And I'm going to add 4 to both sides. And so I get x equals 14. Over here, I'm going to add 4 to both sides. And I get x equals negative 6. Now be careful putting these on your number line. This is a number line. It should be going smaller to bigger, negatives to positives. So the negative 6 goes here and the 14 goes here. Some of us are just sticking these numbers here without thinking about them, okay? Now we also need to decide if this is open or closed. Because it does not have the equal underneath, I know it's going to be open. Okay, so I'm going to have open circles here. Negative 6 is not an answer, 14 is not an answer. Now, I have shown you guys how to do it by putting in a number. I also spoke to you guys about looking at this inequality and understanding what it means. So I'm just going to put a little aside over here. Absolute value is how far you are from 0. Now in this case, what would make this be 0? What would make x minus 4 be 0? Well, 4 minus 4 would be 0. So what that means is we're kind of centered around 4. Okay, we're centered around 4. And this is saying I want things that are more than 10 away. So more than 10 away. Well, first off, what's 10 away? 10 away on this side would be 14. 10 away on this side, okay, so I'm going backwards, I'm subtracting 10, would be negative 6. So these would be 10 away. In between would be less than 10. Outside would be more than 10. So we want it to be greater than 10. So again, this point and this point would be 10 from the center. And you don't need to find the center. I'm just showing you this, okay, so you guys understand what's happening. And I don't want it to be 10 away. I don't want it to be less than 10 away. I want it to be greater than 10 away. So you're going to be shading out. Okay. And your answer is going to be x is less than negative 6, or, and you need the word or there, x is greater than 14. Okay. Now, if that's confusing, you can put 0 in or another value and see where you need to shade. Where is it true? Where is it false? Okay, number 7. So on number 7, this one you have to be careful of. This is not in standard, this is in standard form. So I'm going to show us how to do this, finding the x and the y intercepts. And this negative 4y, that's what is going to decide if this is going to switch or stay, okay? So if it's in standard form, you want to check it. Now, let me get my composition book for a second to show us the notes we had done the other day, okay? Where we said that if it's in standard form, you need to pay attention to the number in front of your y, because when we do this, we always are asking how it is compared to y. Is it y is greater? Is it y is less? So to get this y by itself, I would have subtracted 5x, which does not switch the inequality. I would have divided by a positive 2, which does not switch my inequality. So this one would have stayed greater. This one here, I would subtract 5x. My x isn't going to change anything because I'm either going to add or subtract to get rid of it. This is what's going to change. I'm going to divide by a negative 2. That's what's going to change this from a greater to a less. And just a little reminder, when we started doing these inequalities, find it, we were comparing them to y. That's why if it's not in y form, you want to be careful, okay? Okay, right here, sorry. So we had seen that if it's y is greater or y is greater than or equal to, we shade it above. But if it's y is less than or y is less than or equal to, we shade below. So you need it in y form. And again, this problem here is not in y form, but you don't have to get it in y form if you pay attention. So this negative 4y, the negative means switch inequality direction. And when I say negative, I mean the negative in front of the y. Let me maybe add that in. Negative in front of y. Okay, so I know that this is going to switch to a less than or equal to. That's what's going to happen here. Okay, so now I'm going to find my x and y intercepts. So to find my x-intercept, I'm going to do the cover-up method. Okay, I'm going to use my pen. So if I cover this up, I get 2x is equal to 12. Okay, I'll jot that down here. 2x equals 12, which means x is 6. But you can do this in your head. So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to put 6 so everyone sees where I am. To find your y-intercept, your x is 0. So that would be gone. And I get negative 4y equals 12. Negative 4y equals 12. So y is equal to negative 3. So negative 3. And this is going to be a solid line. So this is going to be solid. And I'm going to shade below. Okay, so let me draw my solid line. And I'm going to shade below. And that's my answer. Okay, just as an aside for people who maybe want to get this in Y form, okay, let me just kind of do that here in this box. So if I was to get this in Y form, okay, I'm just going to move it slightly. Okay, so if I was going to get this in Y form, I would subtract 2x, which does not change the direction of my inequality. So I have a negative 4y is greater than or equal to 12 minus 2x. Now, this is where I would change the direction of my inequality, because I would divide by a negative 4, divide by a negative 4, divide by a negative 4. So that's where my inequality is going to end up switching. So it was greater than, and now it's going to become less than. Now let me zoom out slightly. Okay, so this is going to become y. It's going to switch to less than or equal to, okay, less than or equal to. And again, before it was greater than or equal to. Negative 3, and then this is a positive. 2 over 4 is a 1/2 x. So again, just to make sure you understand, this is less than or equal to, it's switched. Okay, so if you want to change it, you can. You'll notice that here's my negative 3, my y-intercept. And if I'm counting, it's hard to see the little grid marks. I went up 1 over 2, up 1 over 2, up 1 over 2. So you can do it that way if you prefer. Okay. The next one is nicer because it's actually in the Y form that we like. Okay. So for this one, let me zoom back out. Okay, so for this one, our y-intercept is 3. So I'm going to go to 3, 1, 2, 3. My slope is a negative 2, just to remind us. Some of us are having a little difficulty with slope. If it's a negative 2, think of it as negative 2 over 1. The top number is your up or down. So this is going to be down because it's negative, down 2. And then always go to the right. So if it's positive, go up. And the bottom number, go to the right. If it's negative, go down. And then again, the bottom number, go to the right. So I'm going to go down 2 over 1, 2 over 1, down 2 over 1. And then I'm going to connect this. And for this one, it is a solid line. And it is going to be greater, so it is above. Okay, so it's going to be a solid line, and it is going to be above. So let me graph that. And I'm going to shade above. Okay, and that's my answer. You have to shade on all of these. That is your answer. Everything on the line plus the shading, those are your answers. If it was dashed, the dashed part would not be part of the solution. Okay, number 9. So number 9 is a system. Okay, so I'm going to be graphing each of these in a different color. Okay, now first off, this one is going to be dashed and it's in Y form. So I can look at that and it's going to end up being less than, so it's going to be below. This one here has a little equal, so it's going to be solid. And it's not in Y form, it's in it's in standard form. So I look at that, and since that's positive Y, keep inequality direction. Okay, if it had been a negative Y, I would have switched. So it's going to stay greater than or equal to, which is above. So now I'm going to graph these. Okay, so the first one, my y-intercept is 2. So I'm going to go up to 2. And my slope is 3/5. So just a little reminder, 3/5. Up 3, right 5. So up 1, 2, 3, right 1, 2, 3, 4, 5. Okay. And if I want to go the other direction, then you go opposite. Down 3, backwards 5. 1, 2, 3, 4, 5. Come on. 2, 3, 1, 2, 3, 4, 5. And then I'm going to connect this. This one has a dashed line. Okay. Let's see. I'm going to do this one in pink. Okay. So this is a dashed line. And I'm going to shade below. So I'm shading everything here. Okay. My other one is in standard form. I'm going to find my X and my Y intercepts. Okay, I'm going to do it in my head. I'm going to do the cover up. Okay, and I get 3x equals 12. So X is 4. 1, 2, 3, 4. Okay. I'm going to cover up my X to find my Y-intercept. Again, I'm only putting 0 in for X here, and I was putting 0 in for Y before. So I get 6y equals 12. So Y is 2. I actually have it right here. So this one's going to be solid. Okay. Let's say I'm doing this in green. So this one's solid. And then I'm going to be shading this one above. Okay. So I'm shading above. So you see here is just green. Here is pink. So here, let me just, this is my green part just here. This is my just pink part right here. And this part here where I have both colors, this is my answer. This makes this one true. This makes the green one true. This makes nothing true. This makes everything true. So that's going to be my answer. Okay, so really this part here would be either darker shaded. Okay, these are really not part of my solution. This is. Okay, number 10. So on number 10, we want to write a system of inequalities. We call it constraints. In integrated 3, you guys will learn something called linear programming, and you will write constraints, which are kind of restrictions or limitations on resources. And you'll do shading with the inequalities and kind of find a feasible region. For us, we just need to write our inequalities. We're not going to do anything else with them. We're just writing them. So again, these inequalities are going to be called constraints in integrated 3. For the following situation. John is doing a fundraiser for school. He needs to sell at least $200 worth of items. So he needs to sell at least $200 worth of items. The shirts cost $10. The hats cost $8. So he's going to be selling these for $10 He's going to be selling these for 8. He needs to sell at least $200 worth. Then it also says he must sell more than 12 hats. Okay, he must sell more than 12 hats. So we're going to have two inequalities. One's going to be dealing with all the pink stuff, which is dealing with dollars. The other one's going to be this one. So I'm going to have H equal number of hats. I'm going to have S equal number of shirts. And I'm going to do a cursive S so my S doesn't look like a 5 halfway through. Now, the easy one to do is going to be this yellow one. He needs to sell more than 12 hats. That's going to be hats more than is greater than, not equal to. He doesn't need to sell 12 or more. He needs to sell more than 12. Okay, so that's that inequality. The one in pink, the one thing you have to be careful of is this word right here, or this phrase, at least. At least means, at least 200 means 200 or more. So this at least means 200 or more. Okay, so if you have at least 200 bucks in your pocket, you for sure can cover $200, but maybe you can even cover a little bit more, okay? So for that, I'm gonna have my at least, so greater than or equal to 200. And I'm going to be dealing with my $10 per shirt, so that would be 10S. Let me write my cursive S, sorry. Plus $8 for hats, 8H. This is your system of inequalities. These are your constraints. That's all we need to do. Okay, now on number 11, they're giving us a system of inequalities shaded in. And we need to decide what's the difference between all of these. Okay, so you'll notice that you have one that's a line. You have one that's an exponential, okay? So the answer to this is going to be this. This right here is going to be your answer. So I'm going to over here say B makes both true. It's going to make both inequalities true. That's why it's my answer. It's in blue and it's in green. D makes neither true. Makes neither inequality true. Okay. C is right here, okay? C is making the exponential true. So C makes only, I'm going to abbreviate exponential, okay? Exponential inequality true. Okay. And A makes, makes, this was only, okay, makes only the linear inequality true. Okay, so again, your answer to this system would be in here, in section B. This point B would be 1, but anything in this section. Over here makes neither true. Here, it would only make one inequality true. This should make the other inequality true. We need both of them to be true. Okay, next problem, number 12. Okay, on number 12, we're going to be graphing this exponential graph. They want us to sketch it. So remember, this is going to be your start, your y-intercept, okay? So depending on how big the number is, if you want to draw 1, 2, 3, 4, 5 tick marks, that's fine. I'm going to put a point there. Put the number there so we know where it is. Also, for these exponentials, you need an asymptote. So you need to draw your asymptote. And for us, our asymptotes are at y equals 0. So now I need to look at this. This 0.2, it's our multiplier. Okay, we're multiplying by 0.2. So if you're multiplying by something smaller than 1, it's going to be decreasing. So this is going to be decreasing since less than 1. Okay, this is smaller than 1. So it's going to be a decreasing graph. I don't need it to be exact with points. So all you need to do is start with it at high, okay, and it's going to be decreasing, going through that 5, coming closer and closer and closer, but never crossing that asymptote. And that's an acceptable sketch. Okay, on number 13. Number 13, we have a system of equations. These ones we have to solve algebraically. And these are both in standard form. So we're going to use what we call elimination. That's where you want to try to eliminate either your x's or your y's by adding the equations. But sometimes you might have to multiply one or both in order to get them to cancel out. So if I was to just add, I get 8x plus 4y, nothing canceled out. That is no help. We want to either have our x's cancel out, which means that these would be like a 15, one of them positive, one of them negative, or my y's, which means I could multiply this one by a negative 3. That's my easier choice. So I'm going to multiply this by a negative 3, and I'm going to get negative 9x minus 3y equals negative 18. Here I'm going to get 5x plus 3y equals 2. I'm going to add these together. These are going to cancel out, so I get negative 4x. Sorry, not cancel out, they're going to combine to give us a negative 4x. These are going to cancel out. Equals negative 16. And when I divide by negative 4, I get x equals 4. Now remember, you need an x and a y. X comes first, then y. So I'm going to come back to one of my equations. I always go back to my original ones here as opposed to this, okay? Out of these two, I think this one would be a nicer one to deal with. So that's the one I'm going to plug into, okay? So I'm going to put 4 into x, so I get 3 times 4 plus y equals 6. So I get 12 plus y equals 6. And I'm going to subtract 12 from both sides. And I get negative 6, and that's my point of intersection. That's my answer. On 14, exponents, okay? Just a couple little reminders. If I have x to the a times x to the b, I get x to the a plus b. If I have x to the a raised to the b, I multiply them and I get x to the ab. Also, remember, we do not like negative exponents, okay? Now, the first thing I'm going to deal with is this. Let me deal with this first, okay? Then I am going to deal with this and this because I do not like having negative exponents. When they say simplified, they want positive exponents. But let's first deal with this. So I'm going to keep the negative x to negative 6, y to the 4th. Now, on bottom, 2x to the 3rd, okay? 2x to the 3rd is really a 2x times 2x times 2x. That's one way to think about it. Now you'll notice that my 2 is being raised to the 3rd power because I have it multiplying 3 times. That's an 8. X to the 3rd, okay? So my 2 is being raised to the power of 3 and my x is being raised to the power of 3. Okay, and let me just rewrite my y to the negative 2nd. Okay, just trying to do one thing at a time. Okay, now these do not like those being negative. So if it's a negative, remember you can switch it from top to bottom and then it changes the sign. So my y to the 4th is going to stay. My 8x to the 3rd is going to stay. This x to the negative 6 is going to move to the bottom and become a positive x to the positive 6. My y to the negative 2nd is going to move on top and I'm going to get a positive, well, y to the positive 2nd, okay? And you are not done because you cannot have these y's and these x's. You need to have y to a single power, x to a single power. So now, on top, y to the 4th times y to the 2nd, I'm going to add. So I get y to the 6th. My 8, y to the 3rd times y to the 6th, I'm going to add. And I get x to the 9th, and that's your answer. Okay, number 15. Okay, number 15. So on number 15, a couple ways to do it. I think I'm going to make a table. Okay, I think I'm going to make a table. So remember, y equal negative, mx plus b. Okay, so we have 0 and a negative 7, and I have a 5 and a 3. Okay, so the first thing is, if you know your 0, that is going to be your y-intercept. So at this point, I know it's going to be mx minus 7. Okay, mx minus 7. Let me just highlight that so you can see where everything's coming from. Now, my slope, what I can do is I can look and find my change of y and find my change of x. So my change of y, what am I doing to negative 7 to get to 3? Well, I'm negative 7 on the negative side of the x-axis to positive 3. That's actually 10. Okay, I can add 10 onto this and I get 3. Here, what am I doing from 0 to 5? I'm adding 5. So remember, your slope is your change of y over change of x, which is 10 over 5 or 2. So now I'm going to have y is equal to 2x minus 7, just so you can color code and see where everything's coming from. And that's your equation. That's your answer. And on number 16, are the triangles congruent? Why? What is the congruent statement? Okay, so I have these angles that have the same marking, these angles that have the same marking, and I need something else. So I'm going to use this to emphasize this side. Both triangles have that side as a shared side. So that means that this is actually congruent to itself. Okay, NP is congruent to NP. We call that reflexive. Okay, reflexive. Now, are these congruent? Well, the ones that are congruent, side, 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 angle, side, angle, angle, side, angle, side, angle, hypotenuse, leg, if it's a right triangle. Okay, the ones that don't work do not give me side, side, angle, SSA. Remember, it's also a bad word going backwards. And angle, angle, angle would be similar, but not congruent. So I need to decide if any of these are satisfied. So you want to pay attention to what you have in the order that you have them. So this is an angle, a side. I have angle, angle, side. So the reason would be angle, angle, side. They would be congruent. And then when they talk about this congruent statement, I need to match up. So if this is triangle ONP, what corresponds with O? Q. So this would be triangle, put your triangle there, Q, and then N and N have the same marking, okay? And then P. And that's your answer. So hopefully you guys will find this useful for getting ready for our quiz on Friday and help with the D-Day from the other day. And that's the end of the video.